Welcome learners to Form 4 Mathematics. I would like to guide you on application of differentiation in kinematics. Application of differentiation in kinematics, learner. Kinematics is mathematics to do with movement. Let us look at this question, which was tested in kcse in 2018. Here we go. The distance covered by a moving particle, the distance covered by a moving particle through a point O is given by S is equals to t cubed minus 15t squared plus 63t minus 10. This is the distance. S stands for distance or displacement. T is for time. So learner, this is the expression of distance in terms of time. So find the distance covered when t is 2. Find S, distance S when t is 2. So in this case, learner, you just need to come in and write your equation of the distance, the expression of the distance, like that, 63t minus 10. Then you come and substitute 2 where there is t. So S is equals to 2 cubed minus 15. This should be 2. 2 squared plus 63. 2 minus 10, learner. So working this one with a calculator, you'd get 64 meters. 64 meters. We go to the second one here, learner. You are told, find the distance covered during in that period, during the third second. Within the third second, learner, or in the third second, what is the distance covered? When you hear of this word here, during, it means it is the distance covered between time 2 seconds and time 3 seconds. Because the third second, learner, is the second immediately after the second. So the third second is between t2 and t3, that duration there, which is after the 2 seconds there, all the way up to 3. So learner, what is the distance covered between during the third second? You just need to come and substitute 3 in the equation of in the expression of distance. Then you substitute 2, learner, in the same expression, and then you subtract. So you come and write your expression for the distance. There we are, learner. You substitute, let me write it in short, t is equals to 3. What is the distance covered after 3 seconds? You come and fix the 3 there. So 3 cubed minus 15, 3 squared, plus 63, 3 minus 10. Learner, working out this, you'd get that the distance covered at t is 3 is equals to 71 meters. 71 meters. Then you come and substitute t as 2. So you substitute in the same expression of S. This gives you 2 cubed minus 15, 2 squared, plus 63, 2, there we are, minus 10. Use a calculator and you get 64 meters. Learner, you now subtract to get the distance covered during the third second. 71 minus 64, learner, gives you 7 meters. There we are. We go to part C, learner. Part C, you are told to find the time, t, the time when the particle is momentarily at rest. When a particle is momentarily at rest, or when a particle is at rest, velocity is 0. That particle is not moving, and therefore velocity is 0. Velocity is 0. So you get the expression for velocity, you equate it to 0. You come and first write your expression for distance. There we are, plus 63t minus 10. That is the expression of distance. Get for v, velocity, by differentiating. Differentiate this, drop the 3 and subtract 1 from the power. Drop these 2 here, multiply that, and you remove 1 from the power, subtract 1 from the power. This one, if you differentiate here, we had 1, drop it down, you'd get 63t raised to 0. T raised to 0 is 1, so ignore that. Differentiating a constant learner, we know it gives us 0, and therefore this is the expression of velocity. And therefore learner, we are told to find the time when the particle is momentarily at rest, when this velocity is equals to 0. In other words, what is t? So equate this velocity to 0 to get the time. Good. So learner, here we have a quadratic equation. Divide every by 3 to reduce it, to simplify it. So you get t squared minus 10t learner plus 21 is equals to 0. Higher. We need to get another paper. So that we continue. Yes, so we solve this quadratic equation, learner, to get our time. So product sum. Product is 21, sum is minus 10. What are these numbers? The numbers are negative 3 and negative 7. If you add, you get this. If you multiply learner, you get 21. So these are the numbers that we are going to fix here. So t squared minus 3t minus 7t plus 21 learner is equals to 0. Higher, factor out here and something here. So t in brackets t minus 3 minus 7 learner, here you get t minus 3 is equals to 0. Remember, here you put a minus, so that if you multiplied these two, you'd get this positive. So t minus 3 is a common bracket. Take these others like that, equate to 0. So this means that either t minus 3 is 0 or t minus 7 is 0. And therefore learn t here is equals to what? Take this on this side. So 3 seconds, or t is equals to, take this on this side, 7 seconds. So at these times, learner, our particle will be momentarily at rest. Remember that point, learner. When a particle is momentarily at rest, it is not moving, its velocity is 0. So you get the expression for velocity from the expression of s, that is distance, you equate to 0 and you get the time. Now, learner, we now go to the third part and the very last one. We are told, learner, to find the acceleration when t is 3. The acceleration when t is 5, acceleration. So the first thing that you do is to fix here the expression of velocity. What was the expression of velocity? This here, learner. The expression of velocity was 3t squared minus 30t plus 63. It was like that. So to get a learner acceleration, you differentiate. So differentiate this, you get 60 minus what? Bring this down, 30. T raised to 0 is 1. Differentiating this is 0. Differentiating a constant, you get 0. So learner, This is our expression for acceleration. So at t is equals to 5, what is the acceleration, learner? The acceleration, you just substitute 5 here. Substitute it in the expression of acceleration, like that. So this is 30 minus 30, learner, which gives you 0. So acceleration is 0 meters per second squared. There we are, learner. Just a point to note, learner. There is what we call SVA. If you have an expression of distance, to get an expression of velocity, you differentiate this with respect to t. If you have the expression for velocity, learner, to get acceleration, you differentiate v with respect to t. And therefore, we normally write this formula like that. SVA, you differentiate. SVA, you do differentiation. SVA, learner. So all the best, learner, as you practice on application of differentiation in kinematics, mathematics to do with motion. God bless you. Go and practice until you internalize the concepts. Thank you.